Hi all, and welcome to the second part and final part of this tutorial to create the game Dots and Boxes. So currently we have to manually select for the computer player, so in this tutorial we're going to automate that process and give it a little bit of intelligence. So the computer player won't do anything stupid. For example, in this situation it would definitely select that box and get a point. So head into our code. So I'm thinking we'll have to add a delay for the computer so that it doesn't take its turn immediately. That could become hard to follow for the player. So let's create a delay called delay comp. It doesn't have to be for very long, just say half a second, so 0.5. So this will be the seconds for the computer to take its turn. We'll have to keep track of that just as a variable. So head down, similar how we've got time end here, we'll have time, say, comp. Inside our event listeners, we'll need to get rid of these to-dos, these comments here. So this means that the player will not be allowed to act during the computer's turn. And similarly with click, get rid of that to-do there. We'll also need something similar for our computer, so copy that first part there. Just inside our loop function, we'll have to run the computer's turn from here. So how about we create a function called goComputer. Go down and make that. Function goComputer. And the first thing that we'll do is, if it is the player's turn, or time end is greater than 0, that's the end game screen, then we'll just return. We don't want to do anything during the player's turn. Now let's set up our delay here. Set up delay. So time comp will equal math.ceil, that delay that we created, delay computer times the frame rate. So that'll be in frames. So 0.5 times 30 will equal 15 frames will delay the computer's turn. So just up above, we'll need to count down till computer makes a selection. So if time comp is greater than 0, that means we're currently counting down. We'll need to decrement that, time comp minus minus. Now if that reaches 0, if time comp equals 0, then we need to make the selection. So that would be just calling the select side function. We don't want to do that now because we have nothing to select at this stage, so we'll leave that as a to-do. And instead, just for testing purposes, let's just switch the player's turn. So player's turn equals not player's turn. And we need to return until this counts down. Okay, let's give that a test. So it's our turn. The computer waits for 0.5 seconds, does nothing, as we expect, and we have another turn. But it means that the logic, and make sure that we can't click anything during its turn. We can't. Great. Yep, it seems to be working okay. So before that countdown ends, what do we need to set up? Well, we kind of need to randomly choose a square, don't we? But it needs to be in some kind of priority order. So randomly choose a square in priority order. Priority order. Now what are those priorities? Well, if we're playing the game, the first priority would to be always score a point, wouldn't it? To close a square. So how about we say select a square that has 3 sides completed. By doing that, the computer will score a point, won't it? Now the next priority will be to select a square that doesn't give away any points. So that means it has 0 or 1 sides completed. And the worst priority, the final priority, would be to select a square that gives away a point. So select a square that has 2 sides completed that means the computer would be adding the third side, and that would give the player an opportunity to score. So that's the worst priority. We should really do this before all of this occurs, so let's put that up there. So the first priority, how about we set up an options array? We'll need to set up some sort of options array for the computer to select. So set up the options array. So let options just equal an empty array, and we'll give it some rows. So options 0, that will be the first priority, will equal that, just an empty array. And we'll make a row for each of the priorities. So basically that means that the computer will try to choose something from the options 0 first. If there's nothing there, it will choose something from this array, and if there's nothing there, it will choose the worst option. So to populate these options arrays, we'll need to loop over our squares array. So for let I equal 0, I is less than the squares dot length, I plus plus, loop over the columns, let j equal 0, j is less than the squares 0, so the first row, its length will be the number of columns as such, j plus plus. Now how can we tell how many sides are selected on each square? Well, we have a property for that. So let's put a switch statement in here. Switch our squares I, j dot num selected. That tells us exactly how many sides are currently selected. So I'll switch that. So for case 3, so this is our first priority. First priority. So a square that has 3 sides completed is the first thing that we'd like to select. Well, we can just simply push that to our first options row, options 0. So options 0, push this squares ij, right? And we can break there. And we'll do a similar thing for each of the priorities. Okay, so for the second priority is select a square that has 0 or 1 sides. So we'll have to case 0 and case 1, that'll just flow through. That's our second priority. And we'll push that to our second row of that options array. That's all we need to do. And the worst priority, which is case 2, so select a square that has 2 sides completed. That's our third priority. We'll push that to the third row of our options array. So next, let's randomly choose a square in priority order. So all we have to do is set up an option. So a single option, let option. And if the first row, so if options 0 dot length is greater than 0, that means we have something to choose there, don't we? So we can say option will equal options 0, and we'll randomly select the column. So if there's more than one, well, anyway, we'll randomly select it. So math.floor, math.random, random times the length of our options 0, so the length of that row, options 0 dot length. So that should randomly select a column. So we'll do something similar for each of our options rows. So else if options 1's length is greater than 0, we'll want to choose something there, won't we? So options 1, math random, options 1 dot length. And finally, options 2, option will equal options 2, and randomly select the column. So now we'll have to get the square's coordinates, won't we? So get the square's coordinates. So let's create a variable called, say, let chords. Let chords equal option dot, Probably the best thing to do here is to create a method inside the square object. So let's just make up a name now. So get free side coordinates. So that'll return the coordinates of a free side, a randomly chosen free side on that square. And ultimately what we'd like to do is go highlight side, which takes x and y. So it'll be like coordinates.x, coordinates.y. So let's go down and create this get free side coordinates in our square object. So just remembering that to be within this square, we have this contains method. X is greater than or equal to this dot left, x is less than this dot right, y is greater than or equal to this dot top, and y is less than this dot bottom. Just keep that in mind. So head down to just after draw sides, and we'll create this dot get free side coordinates, which will equal a function. So what do we want this function to do? Well, we want it to return the coordinates of a random free side, don't we? So return random free sides coordinates. Now remembering when we highlight, in our highlight method down here, when the player hovers their mouse over one of the squares, it will determine the closest side and select it, or highlight it, right? So we need to generate some valid coordinates here for each side. So valid coordinates of each side. So let coordinates bottom equal, so we'll create a small object here with x and y inside it. So the x coordinate will be halfway across the bottom, right? So we can go this dot left plus this dot width divided by 2, that's halfway across. And the y coordinate will be the bottom, but remembering our contains function above, we have to subtract 1 from that to make sure that it's inside this square. Okay, so let's do something similar for each of the directions, each of the sides. So coordinates left, coordinates right, and coordinates top. So coordinates left, the x value will be this dot left. We don't need any of that. The y coordinate will be halfway down. So it'll be this dot top plus this dot height divided by 2. Coordinates right will be this dot right. Now we'll have to subtract 1 from this, plus, get rid of that. And the y will be halfway down, so the same as this. And the coordinates top, the x location will be halfway across the screen, so we can use that one there. Oh, that's what we have there. And the y value will be this dot top. So next we'll have to choose a random free side. So how about we set up an array? So let free coordinates, let free chords equal an empty array. And then all we have to do is check whether this square has each side selected or not. So if not this side bot selected, so if this bottom side is not selected, we can push it into free chords. So free chords push the coordinates that we created above, coordinates bottom, and we'll do this for each of the sides. Okay, so for side left, so if the left is not selected, we'll push the coordinates left. If the right is not selected, we'll push the coordinates for right. And if the top is not selected, we will push the coordinates for top. Pretty simple. And all we have to do is return a randomly selected element of that array. So return free coordinates and math.floor, similar to what we've done before, math.random. multiplied by the length of our free chords. So it's freechords.length. Okay, that should be okay now. So let's head back up to the function where we call this, so our goComputer function. So we're getting the square's coordinates, yeah, and highlighting that side. Just remember that we had a to-do up here. To-do select side. We need the computer to select the side after the countdown has finished. So we can get rid of that temporary code. So let's try that out. Okay, so it's our turn first. We select a side. Did you see that the computer highlighted that first, then selected it? It gives us a little bit of a visual indication. Yep, that did it again. And again. It seems to be randomly selecting a free side. That's great. Now let's try to give it an option to get a point and see if it takes it. It certainly did. We'll keep playing. Did you see there it gave me a free point? Now it shouldn't have done that, but I think I know why. Because it randomly selected this square, which at the time only had one side. So that was a valid selection based on the way we've programmed it. It didn't take into account its neighbours at all. So we'll have to write some code to fix that up. But otherwise it's a perfectly playable game. The computer will make some mistakes occasionally, which is fine. Maybe you could classify this as an easy game. Let's just finish it off. Okay, it took that opportunity. That's good. Anywhere I can choose here. I'll try to win. It gave me a side there. I can get a lot there. Now I'll have to give away some here. And it gave me that. And I tricked it by giving me the last few. So yeah, it plays reasonably well. We just need to fix up that small bug, that's all. So head down to where we set up our priorities. Now the first priority, that case 3 there, that's fine. If the computer can choose a square where it can gain a point, it should always do that. The third priority, so if the only option left is to choose a square which gives the player a point, well, so be it, right? It's this middle priority that we need to set up some logic. So how about we select some sides? Well, let's create an array first. So let sides equal, and we'll probably need to set up a function here called, say, get valid neighbor sides or similar. And we'll pass the row and column, so I and j. Right, so if that comes back with nothing, that means our current cell that we're selecting has no valid neighbours. We'll always be giving away a point in that case. So it shouldn't be priority. It shouldn't be the second priority. We should push it up to the third priority. If that comes back with some options, then that's great. That means we can use this square and select a valid side. So we'll have to dynamically set the priority here. So let priority equal, well, if the sides.length is greater than 0, that means we have some options. So we can safely assign that as this priority. What I mean is this priority here, right? The second row. Otherwise, it's going to be a third priority. It's no good to us. We'll stick it into this options row. And we'll just put that there. So options, square brackets, priority. So we'll have to put this sides information into our options array so that we can use it. So how about, instead of just pushing the square, we'll create a small object. So just using curly braces. So square, colon, we'll pass the squares ij, and then we'll have sides, colon, and we'll pass that sides, the sides variable that we just created there. To keep things consistent, we'll have to do a similar thing for each of the option rows. So in the first priority, just paste that in there, and the sides will just be an empty array. And we'll need to do the same thing in the third priority down here. So the logic will be, if the sides has anything in it, we must select one of those sides. Otherwise we'll just do what we've always been doing, select a random side. So we'll handle this function soon. Let's just go down and look at this logic. So we randomly choose a square in priority order. After that we'll need to randomly choose a valid side. So randomly choose a valid side. So let's set up a variable. Let side equal null. So this will probably be null half the time. So if option, so we have an option already. If option.sides.length is greater than 0, that means we have some valid sides and we must select one. So we'll just randomly select one. So side will equal option sides. Option sides, it's an array. So we'll just do a math random here. So math floor, math random, multiplied by the length of that option sides array. So option.sides.length. That's good. And we'll also have to modify this so that it works. So option now has a property called square. So option.square.getFreeSideCoordinates. And we'll have to change this, we'll have to modify this function to accept a parameter called side, which could be null or it could be a side. So let's go down and add that parameter now. So inside our square object, in the getFreeSideCoordinates function, let's just add side as a parameter. So valid coordinates of each side is fine. Just under there, let's get coordinates of given side. So let's create a variable here called letCoords equal null. And then all we have to do is switch we can use a switch statement to switch through our sides. So switch side. Now case side bottom. What do we want to do? Well, all we want to do is say set coordinates. So coordinates will equal our chords bot. Right, the one that we worked out up here. We can break there. And we'll need to do a similar thing for each of our sides. So side left will be chords left. Side right will be chords right. And side top will be chords top. Now, if that chords doesn't equal null, we can safely return it. So return requested sides coordinates. So if chords doesn't equal null, because we set it to a null initially, don't we? Then return chords. So for example, if side was null, it would go through here, coordinates is null, nothing would happen, and coordinates would still be null, so it would continue on with our normal code. So otherwise, choose a random free side. Good. So head back up to our Go computer. So we've randomly chosen a valid side. We get the square's coordinates. We've just fixed that up. That should be okay. There's only one last thing that we need to do, and that's to implement this getValidNeighborSides function, which takes a row and a column number. So just above Go Computer, here we go, just up here somewhere. Function getValidNeighborSides, which takes a row and a column. And we can just say let sides equal empty array, and let square equal squares row column. So we need to check each side. So let's start off by checking the left-hand side. Check left. Now we only need to check this if the left-hand side of this square is not selected, right? Because if it's selected, we'll never choose it anyway. So if square, so this will be not square dot side left dot selected. So if the left-hand side is not selected, we can also check for the column. So if col equals 0, well, that's a valid square, isn't it? That means there is no neighbour to our left if the column equals 0. Or if the column, squares row column minus 1, so that's the square to our left. If that square's num selected is less than 2, that means we could safely select this side, right? So if it's less than 2, it's going to be 0 or 1. It doesn't matter if we add an extra side to that. It'll still be a nice, a valid move. Right? So if either of those things are true, then we can safely add the left-hand side to our sides. So we can go sides.push side.left. So we'll need to do something similar for each of our sides. So let's copy that 4 times. So check right. Okay, so if the square side right is not selected, and the column equals, well, the column will be the length, the right-hand side. So the column will be squares 0 dot length minus 1. So that'll be the far right side. Or squares row column plus 1, that's the square to our right. Num selected is less than 2. Then we can safely push the side right. Okay, check top. So side top is not selected. Now it'll be if the row equals 0, so that means there's nothing above us, we're on the top line already, then it's a safe side to click. Or, so we don't need the column here, or the row, squares row minus 1, so that's the row above us, num selected is less than 2, then we can add the top side. And lastly, the bottom. If the square, the side bottom is not selected, and the row equals the length of the squares, right? Squares dot length minus 1, so that's the bottom row. If we're already the bottom row, that's fine, that's good. Or the row to our bottom, which is the square to our bottom, which is squares row plus 1 column, num selected is less than 2, then we can add the bottom as a valid side. Right? So all we have to do now is return the array, return sides, and hopefully everything should work. Okay, let's try a go. Oops, we've got an error. Type error. Square side left is undefined. 203. 203. So this is undefined. That probably means square is not coming back with anything. Square, oh, I see. Squares is a 2-dimensional array, so we should have 2 lots of square brackets there. That was a silly mistake by me. Let's give that a go now. Let's reset it a couple times. Okay, so the player had a turn. Let's just have a go at this, see if it does the right thing or not, and doesn't make any silly mistakes. So far, so good. It's not choosing anything silly. Now I have to make sure I don't choose anything silly. Okay, so it put one there, but that's because it's got no other option. If it put a piece anywhere else, it's going to give away some points. So it's chosen that particular location. We'll fill that in. Now we have to give away some points here too, so I'll choose the shortest route. It gave me that one. Fill it in. Anyway, it's doing the right thing. It's randomly selecting what it can. I'll just give it the last couple points. Ah, good. So I think it's working well now. Anyway, that'll do us for this tutorial. So we've created the game Dots and Boxes, and we've automated the computer player. You could probably improve the computer slightly by adding some more advanced algorithms, but I think we'll stop there for this tutorial. Feel free to download the code and have a tinker with it yourself. Until my next video, talk to you then. Bye!